Welcome to Master AK tutorial. Today we want to talk about simple harmonic motion. Simple harmonic motion is defined as the motion of an object whose acceleration is directly proportional to its displacement from a fixed point and is always directed towards that point. Okay, the meaning of this definition, we are going to explain the meaning of this definition in the examples of simple harmonic motion. Here on the board we have two examples of simple harmonic motion. We have this, which is the oscillation of a mass M. This is the mass M attached to an horizontal spiral spring, and this, which is a simple pendulum bob. This is a simple pendulum bob that we oscillate through a small angle theta when displaced from its position of rest, which was here. Okay, now I want to explain the definition of simple harmonic motion. The first thing about simple harmonic motion is that the acceleration is directly proportional to the displacement from the fixed point. Okay, so in a simple harmonic motion, the acceleration is given as a is equal to minus w square y, where y is the displacement and w is the angular velocity. Okay, now this formula has been derived in the video on rotational motion, so you have to watch the video on rotational motion to understand how we got this formula. The acceleration for rotational motion is the same as the acceleration of the simple harmonic motion. Okay, the only difference is the minus sign, and I'm going to explain why there is a minus sign. Okay, now for the definition, you can see here that the acceleration is proportional to y. The coefficient of proportionality is minus w square, and this is a constant. We've said it before, in a circular motion the angular velocity is always constant. Okay, so because of that, this is a constant, therefore a is directly proportional to y, and the constant of proportionality is minus w. That is why we now say that in the simple harmonic motion the acceleration is always directly proportional to its displacement, which is y. Okay, now the second one is that the acceleration is always directed towards a fixed point. Okay, and the fixed point is generally the position of equilibrium. Okay, the position of equilibrium is the position at which the object was initially before being displaced, and when it is at the position of equilibrium it cannot move, it will remain there forever until somebody come and displace it from the position of equilibrium. That is when it starts oscillating, and that oscillation to and fro is called the simple harmonic motion. Okay, now the minus sign. The minus sign shows that the acceleration and the displacement always have opposite sign, yes, but also opposite direction. Okay, that is the the acceleration and the velocity. The acceleration and the velocity always have opposite direction. That is the meaning of the minus sign. Okay, so and I'm going to explain. I want to explain it now. So when you take the mass M and you displace it, let's say you displace it to this position here, you take this, you pull it to this position here. Okay, so when you leave it, it will now start oscillating left and right. That is, it will come here, it will come back here, it will pass through this position, come here, from here pass through this position, come here, and that oscillation to and fro is called the simple harmonic motion. Okay, now we said that the velocity and the acceleration have always opposite direction. What does it mean? Okay, I want you to note something. When an object is moving along a direction, let's say an object is moving along this direction, the velocity will always be along the direction of motion. Okay, the velocity also will have this same direction. Okay, Now, when the acceleration is positive, therefore acceleration will also have the same direction as velocity. But when the acceleration is negative, therefore the uh, acceleration will have opposite direction. And how do you know what an acceleration is negative? An acceleration is negative when the velocity is decreasing and the object is moving. Okay, so if the object that is moving, the velocity of that object is not increasing with time, that is, it is decreasing, therefore it means the acceleration is negative, that is less than zero. Okay, now if you look at the simple harmonic motion here, when the object moves here, that is from this point to the right hand side, it's being pulled by the spring backward. So therefore, while moving here, that is the right hand side towards the right hand side, the velocity will be decreasing because it's being pulled backward until you get here where you have no velocity again, that is zero velocity. Velocity is equal to zero here. Okay, from here to here, the velocity here, the velocity was not zero, but because the object is being pulled by the spring backward, the velocity will be decreasing and it will attain zero at this point here. So which means what? Which means that the acceleration is negative, is having the opposite direction to that of the velocity. Like because the object we're moving here, the velocity has the same direction as the motion. The direction of motion is the direction of the velocity always. But here you can see that the velocity was decreasing, therefore acceleration has opposite direction. The same thing when the object moves from here to here. When the object moves from here to here, the velocity is always in the direction of the motion, that is here. And because the spring is being compressed, so the spring will be exerting a force in the opposite direction. So because of that, the velocity will be decreasing, and because the velocity is decreasing, the acceleration will have an opposite direction, that is this direction. So you can now see that throughout the motion of the object, the direction of the motion is different from the direction of the acceleration. Okay, so that is why there is a minus sign here. Okay, the same thing can be applied to the simple pendulum. Okay, so I think we're going to stop for today at this junction. We're going to continue on the simple harmonic motion in the next video. I hope you have liked this video. If yes, share it, like and comment. So thank you. See you in the next time, in the next video. Thank you.